We can see.
Is the screen visible, guys?
Yes, yes, yes.
Okay. So let's just revise the monetization. Okay. Just once. So it looks more like a scratch pad. Okay. Okay. Am I visible?
Yes,
Yep.
Arya.
So you guys remember the architecture, right? Guys?
Yeah, yeah.
Okay. Okay. So the problem we were solving was, so there is like whole transcript, okay, from which we need to analyze. So among the transcript, what would be placed as agendas, and depending on like the number of agendas, we need to create like three deliverables. One is summary, the other is XML diagram if it can be if it can be drawn. Okay, that's a choice. And the third is description, correct? Process description. So these were the three deliverables that has to be delivered from each of the agendas. Okay, let's say there is three agendas. So all these deliverables for all these three agendas. Correct. So this was the problem we were solving. Okay. So let's just get to the solution. Okay. So we have explored it already. So let's explain. So this is the input transcript. So can anyone guide me? Like one of you guys, or both of you? Guys,
Yep, yep. What do you need?
like this is the transcript, this is the input. So how the flow goes. So the architecture we designed, right?
Mm-hmm.
Yeah.
Yeah, you were
So
about to
So
divide it into
creating,
5K tokens.
yeah,
okay, so we will divide this whole transcript. Okay, based on some n value, correct? N could be like 5K for now. It's fine. So this, let's assume this is 15K. So now we have 5K each section, correct? Yes. Going forward.
Yep.
So we will pass this each of this section. So let's just consider one section for now. This first 5K, we will pass it to an agent. Okay. So what's this agent's purpose is? So this agent will take up
instance,
this 5K and actually create me a
instance.
yes. So yeah, so we will be not just cutting this as 5K tokens. So we will be implementing what's line numbers, correct? So why can't we consider timestamp? Because it can hallucinate very easily, the timestamps. So that's why. So line numbers, yeah, it can even hallucinate line numbers, and we have created a plan for it, right? So we to deal with the same. So we will be generating that next 50 words alongside that line number, and we will check each time if that line number exists. So what's the work of this worker agent? Let's say worker one. Okay. So worker one agent, it has to respond me with a JSON response where it has to have like multiple dictionaries. Within each dictionary, there is an ID. Okay. So let's say ID one. So there is a value, and there are keys such as like start line number, okay, end line number. So this may be 0, it may start with 0 or 1. Okay, so let's just say 100. 100 is the line number where the end is. So here I get a summary, and here I get a flag that if it is continuous or not. Okay, for start we
Mm-hmm.
can add it as start. Fine. Okay, so we can so these flags, they are to make sure the next set of agents, right? So there is another agent which is actually reasoning agent, correct? So which is teaching all this. It is trying to make sense out of all this data. So for that to give a reference, so what is the placement of these particular dictionaries and data? So for that, we will be having these flags. So the flag may suggest, so if this is continued or this agenda is completed here at this point in this particular statement. Okay. So all such details could be mentioned in this flag. So there could be multiple flags again. So this is a dictionary, okay, where the only instruction for this worker LLM is worker agent is, so it has to remove all the empty noise, okay, all the small talks, which doesn't account for any agenda, okay, which is not productive enough. Or let's just say there is a small talk that's happening, which doesn't make sense, which would not be a main agenda. So it can remove all these things, okay, all the unnecessary talks, all the noise, okay. Its main agenda is to remove all this and provide with a dictionary where, so whatever it removed, right? So whatever has to be kept, those line numbers has to be dictated, and the reason for it to choose those, and the summary of it. Okay. So this worker when agent, we will give me a response of a nested dictionary where each dictionary within that dictionary will have these IDs. So ID1, this could be ID2, this could be ID3. Okay, there seems to be another column here. Okay, this could be ID2, this could be ID3. Okay, multiple IDs. So in each, it will have start and end line numbers. Okay. So the worker agent, so there is an QA agent attached. So for every agent, right? So there is a QA agent attached, which will ensure that this is the particular response that's been provided, and these are particular dictionary values that are present, and this is complete. This response is complete, and it ensures the line number exists. Okay, start and end line numbers, right? So they do exist in the transcript. This is what this QA will ensure. And if there is an error, it will look back with the feedback. Okay. So once this is done, so let's call it like worker 111, worker 12. Okay. Worker 10. Okay. So these are the worker agents which will be responsible to decode all these 5K tokens, and then all the response that are generated, correct? So that will be passed to this reasoning agent. So where this has to look at all the summaries, all the flags that mentioned, okay, the ID, because the ID represents the flow of data, the flow of the transcript. Okay, ID1 represents, this was the first section, ID2 represents, this should be the second section, correct? So there is an pattern there. So it has to consider all these things and has to stitch me, check on the number of agendas. Okay. So once it finds the number of agendas out of the responses from worker 10, worker 11, worker 12, right? So now it will respond me back with so this will respond me back with a nested dictionary. Okay, where the number of dictionary here are directly proportional to the number of agendas that are being discussed. Okay, so let's just say there are two dictionaries here. So dictionary one, this is an agenda one. So dictionary two, this is an agenda two, which contains all the line numbers, okay, start and end line numbers that I can stitch now. So depending on the response I get here, I will introduce a Python function. So I will iterate through this first dictionary and all the line numbers mentioned, right? So I will stitch the whole new transcript here. Okay, and this transcript is only responsible for agenda one. And depending on this output, the dictionary two, I will create one more transcript where this is responsible for only agenda two. Make sense? Yeah, there could be multiple agendas, right? So yeah, that's the summary. So that's the transcript responsible for this agenda one. Now I can pass this to deliver three deliverables. So maybe worker agent one, worker agent two, worker agent three, which will create me summary. Okay. So we can avoid this creating this agent by asking this reasoning agent, right? So as it creates the dictionary with the line numbers, right? We can ask it to reason why it did it and the summary of that particular agenda. Okay. From here, we can actually get the summary instead of getting one more agent do the same task. Make sense? Since it is already summarizing the things, it is stitching the things, it knows like what's the agenda is. So we can directly ask it the summary. Okay. So with that we dealt with. So we will create XML if necessary. Okay. And description. Okay. For all the agendas. So there are two agendas here. We have summary already. So XML if necessary and process description. Make sense? So this was the flow
Yep.
which we presented, correct?
Yes.
Mm-hmm.
Yes. So here we need to understand, like we in particular need to understand like for each of these, right? For each of these agents here, which I mentioned, like let's say the worker agents mentioned in this section, or worker agent mentioned in like this reasoning agent, worker agents mentioned here. So they will all have a QA loop, correct? Which will check if the results generated by those particular LLMs internally are accurate, and if yes, it will let the data flow. If not, it will loop back, correct? With the feedback. So this is what we learned from like agent session. So if this is the case, so what we will check like ultimately? So we are checking, we have these QA agents every time, right? So at every particular step, every particular node, we can say, okay, we have this QA agent which is correcting its mistake, the mistakes done by that worker agent. So then why do we need a QA test? So let's say there is an application built. So you have this spy test, right? So which it has to go through. Every time it has to go through this, there is a testing that's happening. So what we will test, if everything is already feedback given and there is a perfect answer that is being generated. So what's the QA analyst has to do here?
I mean, I think robustness.
Okay, so we check for robustness, how good the
Mm.
system is, correct?
Yeah.
Okay.
How
Maybe
accurate it should be, the information from what we acquire from the meaning.
exactly accuracy, or in our terms, it's faithfulness, correct?
Correct.
Correct. Next.
Mm,
Saurabh, any inputs here?
Yeah.
Just thinking.
Okay.
Avoiding hallucination.
Yeah.
Okay. We should check for hallucination. Right.
Do something we do with performance, like in how much, like what is expected outcome and like performance of it, like tokens or something. Okay, latency.
Latency.
Can we say latency?
Mm-hmm.
Okay. So let's consider these are the things we need to verify now. Okay. So as an AI quality analyst, you are supposed to verify all these. So there is a system that is providing us with the solutions, but we have to evaluate the solutions anyway, right? So what is worker agent? So let's understand the difference between the quality analyst. We will be putting up, okay, cross model evaluation, all these techniques, and the quality analyst that is actually giving the feedback to this worker agent. Okay, so this is so the main purpose of this quality analyst would be very like custom made and more like very peculiar. Okay, so here this quality analyst will ensure with given this 5K tokens, right? So there are things being generated. There is a dictionary being generated where the line numbers are mentioned. So it has to verify that line number exists. Okay, and it has to verify that the dictionary format is complete. Okay, it is good to go next. Okay, that is the only sole purpose of this quality analyst. So it will not evaluate if the summary generated is accurate, if the things classified is accurate. So it is not actually analyzing the whole truth here. Okay, it is not evaluating the work of like whole work of this particular agent that's generating this. Okay, so we have given it the instruction that it has to check like the page numbers. It has to check with the format, Okay, if it exists, yeah, good to go. We will pass it to next. Correct. So that's the only job of this quality analyst that's been present here. Provide the feedback. And there is a reasoning agent, and there is an again the quality analyst that sits there uh, to critic. So let's not call it quality analyst and critic agent. Okay. So this critic agent is to check for like if the generated final response is complete. Okay, it is formatted properly. If the keys that are necessary are mentioned there, the values necessary are mentioned there. Okay. So this quality analyst won't be as we know, this critic agent. Okay, whatever the critic agent, right? So internally, it's an LLM being in loop, and this is a very small or let's just say low cost model. Correct. So this is a low cost model. So we can't provide it task to evaluate the whole thing that is being generated by other agents, other LLM. Okay, so that was our the point that we need to remember. So these are low cost models which can do the tasks with so like checking the response and ensuring there are keys that are necessary. Okay, all these things. So once these steps happen, right? So once this three stage where it is getting the things out of 5K tokens and there is a reasoning agent. This is the second stage, and the third stage is creating all these deliverables. If these happens, right? So overall, how the flow goes for a particular transcript. Okay, let's say there is a particular transcript. For that particular transcript, how is the response generated, and were there those number of agendas, and were the XML was the XML that's generated the diagram, right? So was it compatible to certain format? Okay, let's say BPMN 2.0. So is it compatible to that format? Okay, so this agent is checking if the actual XML is generated. Okay, we can ask it to compare it to like compatibility to, no worries. But yeah, ultimately our keyword, what it does is, so it will evaluate if it is compatible, and then the things that are mentioned in that particular diagram, right? If they are accurate, if they are faithful enough with the ground reality. Okay. So we need to check this, and for that we need keyword. And yeah, we need to check for hallucination. We need to check for like, let's just say there is an like this worker 1 2, right? So this loop like 3 loops in order to answer. So there is a latency that's increasing in this particular stage, right? So the worker 1 0 and like in the first loop, so worker 1 2 has to go for 3 loops. There is a latency that's happening, and we need to record this. So that's where monitoring comes in. So how do you record this? Okay. So if it was a so they have print statement. Okay. So the execution goes as a flow, and through the logs we can definitely understand what's happening and when. Correct. So say is my screen visible, guys?
Yes, yes, yes.
Okay. So here is a simple code. Okay. Yeah, I have mentioned it as worker agent, but there is no LLM involved here. Okay. Not involved any loop. So there are these two functions. So there is an asynchronous function call that's been happening here. Okay. Asynchronous means like parallel processing is happening. And once we start it, right? So let's just say I have put up like print statements. So there is no LLM involved here. So these are like custom print statements. So let's just say I have attached to print statements here. So how do they look? So this is like just a presentation. Okay. Orchestration started, fanning out parallel workers. So worker 0 started, worker 1 started, worker 2 started. Okay, great. Worker 3 started. And here comes like there is an information about worker 3 now randomly. And then there comes a warning. So some draft was like rejected from loop 1. Okay, so there is an worker agent info is given. So here comes like one more worker 1 agent, worker 3, right? So there's a list of messages I'm saying, and I can't make sense out of it because the flow is not linear here. So when you say the processing is parallel, right? So yeah, Just a second, guys. Okay. So when you say processing is parallel, okay, this loops like I will run this LLM parallel, okay, into 3 states. So it has a cost that is, so now the flow is not linear. Okay, there is no LLM call one happening, and if there was a LLM call that's been happening like this, so LLM one waits, and the response of LLM one is given to LLM two, and response of LLM two is given to LLM three. So this is more of a linear approach, where I can put up print statements for this particular call, print for this particular call. Let's just say LLM calls are happening like parallel. Okay, 3 calls are happening. So how will you print this? We have to trace this anyway, right? In order to trace this, I can't go linear because the flow is not linear here anymore. So using the print statement or the log statements, uh, that won't be helpful for me because it will create more chaos. Correct. So how will you solve this? So we need to check through this. So yeah, depending on like tracing these, right? So we will get to know like what's the latency was, where exactly our which model or which worker agent, okay, took the most time, and where it failed and why it failed. So in order to check like why it failed and what's happening there, we need to understand that this is failing, correct? So in order to understand this is failing, we need to trace it. Okay, so there are multiple calls that are happening, and which one did it fail or which made the application respond late? Okay, we don't know it. User provides the transcript and he sits quiet, and there is a response that comes in. Correct. So this black box, he doesn't know what's happening here. So for one transcript, it may respond in like let's say 15 seconds. Okay. For the second transcript, it may take 30 seconds because some worker agent messed up and it has to reiterate. Okay. So and this number can increase. Correct. So where did the flaw came in? So for that we need traceability. So how will we trace it? So we have tools. Okay. So Azure Phoenix and we have LangSmith. Okay. Which can actually trace this parallel flows. Okay. So how will that work? Let's just understand. So
Can you
in
repeat the tool's name, Maria?
yeah, sure. So yeah, LangSmith is one famous tool. Right. LangSmith is one famous tool, and then comes Azure Phoenix. Okay,
Okay.
I mentioned it here, I guess. Okay, right. Those were like famous tools which are like used as a standards now, right? So it is yes. So how does this respond is? So how does we get a trace of it is? So let's just say worker agent one. Okay. So there is agent one and agent two, which are processing parallel. So what it will do is, so until now the execution was linear. So it will form a like there is an linear flow, and now there is a parallel flow. Now the flow is parallel. So what it does is, so it creates something like agent one. Okay, so the dictionary of this flow. So it will create a dictionary, and the flow is written here. Okay, and there is another dictionary that agent two. So the flow of this is being separated here. Okay, the logs of agent one will be written in under like agent one. So this becomes a parent node now, and this information, the logs, becomes a child node. Okay, so it will create a hierarchy. So this is the first flow. It went like this. This is the second. Okay, here the parallel processing happened. So it will create the separate dictionaries for this. So how this will be represented is, so let's say one, let's say two. So one will have the value of like the logs. So one will have like everything, right? So within one, there is two that's happening. And within two, there are two dictionaries. Okay. So these two dictionaries are, let me just remove this. Okay. So we have two dictionaries here, so two processes in parallel. So we will have two dictionaries. All the logs of that particular flow, right? So this is flow 1, flow 2. That particular logs are arranged here. And let's just say there is an like 3 execution here. So within this dictionary, there will be 3. Okay. By this, we can better understand the flow. Okay. It can also record tools like LangSmith, correct? So they will have like huge dashboard for us, something like okay, I haven't logged in yet. Okay. So yeah, I can present it tomorrow, no worries. So this LangSmith will have a complete dashboard, which almost look like this. Okay. So all the requests that are being done, it will record all the number of LLM calls that have happened. Okay. It will log the latency it took to go from, let's say, so this dictionary, or what's the latency it took to complete these logs, and what's the latency it took to complete this process too. Okay, everything is logged here. So depending on that, looking at these logs, we can easily identify which particular worker node or which particular critic node or which particular process did it took time. Okay, where did it fail? Okay, so not just that. So worker 1, so it responds with certain dictionary. So this dictionary itself could be recorded, correct? So this creates observability. That is, you can exactly see what's happening from, so what output came from which node, and what was the feedback that's provided, and what was the next iteration output that was created. Okay. And then depending on this, we can fine tune like, yeah, depending on these details, right? So we can fine tune that application. So we can fine tune the prompt, we can fine tune the architecture, we can introduce some other workarounds if necessary. Correct. Uh, so this is the necessary of like observability and let's say tracing. Okay. So we would be using LangSmith for it. And I will present the dashboard tomorrow. No worries. All right. Okay, for our architecture, for our particular architecture, so the first worker agent set, right? So process 1, where worker 1, 0, 1, 1, and 1, 2 are there. So these will have, so here, we don't have to use the same models for everything, okay? But it is essential that we use same family models. Okay. So same family models we need to use because let's just say Gemini. Okay. Let's just say Claude. Or let's just say OpenAI. If we shift between these models, right? So you have to authenticate this and get a response, and you have to authenticate this. So switching between interacting with the same network is much faster than interacting with like different particular providers. Okay, cloud providers. Okay, so that's why having, let's just say Gemini, there are certain models. Okay, you have to use. So use Gemini and use those models, different models. Okay, so for reasoning, for reasoning, you don't need a small model. You need a reasoning model, correct? So generating a text isn't a choice there. So it has to reason its choices. So there, the reasoning model is important for creating this particular, let's say, dividing this 5K anchors, 5K tokens into multiple dictionary. So here, most of the reasoning is not, I mean, not important because we are just generating the whole summary of it, correct? Considering the summary, our reasoning model will generate the agendas. Okay. For this, we don't need a strong reasoning model, but yes, for reasoning model, for reasoning phase, we need a stronger reasoning model, and then we are creating XML diagrams. Correct. So we need a model which are good at creating these diagrams. Okay, we could increase those models. So we don't have to blindly use, let's say, OpenAI, like ChatGPT 4. Okay, so we don't have to use this blindly every time. Okay, so depending on the work that's necessary for that process, right? So we can adjust the models, but make sure for just to increase the latency. Okay, so there is a thumb rule for this again. So using a same model, same family model is not necessary. Okay, you can use any of this, but yes, using the same family model often uses like less latency than using the different models. Okay. So yeah, so the time involved here for the first process which we discussed, the time would be low. For the second, the reasoning, the time would be like little bit more because there is a reasoning happening. Okay, so because this is a parallel process, this is low. So all the worker agent is taking up like 5k, 5k, 5k tokens, and now it starts generating. Okay, that's why it is low. So now it will consume the thing and it will reason its choice. Okay, consuming token is easy. Okay, if you provide like 5k tokens, so analyzing it would be easy for LLM. Then generating the 5k tokens. Okay, token generation takes time. So the reasoning model would be like the process involved here could be little more, and to create XML diagrams, right? So it has to go through like syntax perfection, and it has to make sure it is compatible to whatever application we are looking for, and it also need to evaluate like it at its level it has to follow the faithfulness to correct. So it has to generate the accurate results. For that, yeah, the XML could take time. So for this particular process, right? So this is not particular models, or let's say, so this is a process. This process one may take less time. The process two may take time, and process three would take like more time to generate the XML and the process description. Okay. For our particular solution, for our particular application which we are looking into, yeah, this is the case. Yeah. Okay. So whenever we are creating such applications, right? The application kind of application which we created today. So imagine instead of generating like line numbers, if we ask, so there is a transcript as an input, okay, which is of 15k tokens. Now, so instead of asking for, so all the process is same, 5k tokens, 5k tokens, there is an agent call happening. Instead of asking it to create like two parameters, so start and end. Okay. Let's imagine we ask this LLM to respond back with the whole transcript, okay, by removing all the details where there is a noise. So isn't it easy approach, right? So instead of letting the Python do the heavy lifting, prompting the LLM that remove all the noise and recreate this particular transcript. Okay. Imagine this is not every time, but yes, imagine 2k is the noise among this 5k. 2k tokens are nothing but noise. So now it has to generate 3k tokens, but we know that generation of tokens, generation takes time, correct? So it's almost like 80 tokens per minute, let's say. Okay. So generating 3k tokens is not a wise thing. So what we will do? So we have to make a smart choice. That is the start and the end we are asking, and we are letting the Python do the heavy lifting. Correct. So that's a smart choice. So we have to make sure whenever we are involving agents or LLM, right? So we don't let them do all the heavy lifting. Okay, heavy lifting has to be done by Python. Okay, it is good at it already. So we have to check for this. So the inputs, okay. So we have to generate light outputs, okay, as necessary, because even it's not just about the latency, it's about the cost too. Okay, the more number of tokens you generate, so the more the bill, correct? Looping over it can triple cost, yes. So there is a worker agent, and now it has to go for like 3 iterations. Okay. So there is a latency that is increased for the ultimate output that comes in, and there is a cost that is increasing, correct? So you have to make sure so critic agent, right? So our critic agent is not too tough, okay, So we will let this critic agent, so that's why in the previous example I showed, right? So I'm not asking the critic agent to evaluate the response, the complete response, and analyze the faithfulness, let's say, and adjust it according and give a feedback. I'm providing a simple instruction that check for the whole JSON. Okay, let the formatting be true and let the line numbers. Okay, even we can check for line numbers. Okay, so we can provide it a tool. Not so yes. Imagine 4.0 is here. 4.0 model is doing this generation, and here the critic model is also 4.0. So now it has hallucinated a number. There is no number called 501 line number. Now this particular agent, critic agent, can also accept this, right? Because again, this is an LLM. It can hallucinate. So what we will do is we will write a simple Python function which it has to run in order to check if that particular line number exists. Okay. So if this Python responds with like valid answer, that is pass, okay, then the critic agent will let the data flow. If the fail comes in, okay, then it has to provide this particular whatever the fail, okay, fail message to this particular worker agent. Okay, that's the only task we are providing critic agent to do. Okay, so asking critic agent to do the more tasks will actually result in this number of loops that are happening, right? This increase, and which in turn will increase the cost, because the worker agent generation cost and the critic agent response cost, everything is added. Correct. So every time the loop goes in, it multiplies. And tracing through. So we need to understand like what's going wrong every time. Okay, there is a prompt update. So that junior developer comes in, let's say he updates the prompt. Okay, so he puts the old prompt into ChatGPT and asks, so identify the flaws in this prompt and generate me a new prompt. So ChatGPT will easily generate a new prompt, okay, which would work or not. Okay, and now he copy paste the whole thing. So this whole application, which was working fine, which was supposed to be improved by this junior developer, is now, because of the prompt update, so it is aggressively failing. Let's imagine. Okay, so we have to check through these prompts every time. Okay, so in order to understand the system is failing and where it is failing, we need tracing. Correct. And also to understand like what's the final cost, what's the maximum cost or the minimum cost. Okay, or the average cost. For that also we need tracing. Yeah. Yes. So this particular slide is actually explaining the difference between developer's perspective, not just the developer perspective. So difference between like what's the QA critic. Okay. So the question was simply, we have a application where at each step there is a QA that is providing a feedback and let's making sure the worker agent actually responds back with like good content. Okay. Then why do we need another particular QA section in order to evaluate this whole application? Okay, that was my question. So the answer is the difference between the roles actually. Yeah, you guys give out some points, okay, which were completely valid. Okay, so let's understand like what we are checking with faithfulness. Okay, in loop critic node checks for that particular instance, whatever the input is coming in, right, and the response it needs to generate. So it is only checking that. So our let's say our QA infrastructure, what it will check is, so how good is the final response? Okay, how good were the in between steps overall? Okay, it will evaluate that. So writing a function doxing, okay, adherence is like following the instruction. Okay, so we can provide only simple instructions to this particular QA agent, critic agent. But as of our QA infrastructure, we can add up more instruction. Okay, we can make it like more strict, because it is more of a cross validation method which we will be using, and in the cross validation method. So QA, whatever the agents or LLM we will have in cross validation, right? They will be much superior than the ones which are used in like application. Okay, they can evaluate better. Tracing look efficiency. Okay, so here we will check for latency is okay where it failed, which is getting us like which is making it costly, which step. Okay, building a routing agent. So here we basically check if that particular critic is checking if that particular option that the agent is choosing, right? So if that is good enough. Okay, so there is a difference between the critic agent that are involved into an application and the quality engineer who is creating an quality infrastructure, okay, which checks for which audits this particular application. Okay, so the scale is completely different for developers perspective and QA's perspective. That's pretty much like what I wanted to explain. So yeah. So the observability, right? In LangSmith, it looks more like we will particularly have which section took the most, which section particularly was costly for us, which section took the more latency, where were the most of the calls happening. Okay, all these details will be in a simple dashboard. Okay, within Lang Langflow. Sorry, LangSmith. So it will be more of parent-child relationship through which we will be analyzing the traces. Yeah, this economics is completely particular for our particular application. Okay. This is, so we are saying like we are getting we are creating a quality. Okay, we are checking for the quality of that particular application. So how do we do it? So there is a golden dataset rule. Okay, where we have to create a golden dataset that is. So let's say human in loop or more superior models will process this particular transcript. Okay, transcript one, and will identify the goals. Okay, so we'll identify like each step. It's like what should be the response, ideal response, and then what should be the stitch and the number of agendas and the details. So let's say XML diagram or process description. What are the things that should be mentioned in that particular agendas? Okay, so this we call a golden data set. So this is basically a golden data for us. Okay, so this is transcript one. So we will have transcript two, and so on. We will have like minimum of 20. Okay, so all this transcript data we will put it in our infrastructure such that. So this is more like a steps. Okay, so our QA infrastructure, what it does is, so every time there is an update. Imagine so our previous example, that is junior developer comes in and updates the prompt. Okay, now each time such updates happen, right? So it has to go through this QA infrastructure where so all these 20 transcripts are provided to this application and all the tracing that has been done. Okay, so that is being checked by our QA. Okay, our QA agent is actually, yeah, we can't grade this. We can't grade this using Python because the summaries created by this particular application could be different each time. So we have seen it in like class one. Okay, so for the same input, there could be multiple different outputs, which may sound similar, but not exactly similar, correct? So that's why we can't actually match with the each processes. So what we will do is we will have our agents here, QA agents, which will check. So this is my base data. Okay, so this is the golden data, which the output of that application should resemble. Okay, even if it not resembles like directly. Okay, so we will put up a threshold. Let's say 95% faithfulness. Okay, let's say 90%. So when we put up this threshold, so this particular transcript, it will check through the process one, process two, process three, and it will check through the so how the our application actually worked in process one, process two, process three, depending on like all the traceable elements. and then it will evaluate how good it is. It will compare how good it is. It will provide a number, okay, 0.9, let's say. For transcript 2, it is 0.8. And then it will take up an average. Okay, so average is like our value. Okay, we can keep it average, mean, median. Okay, anything is possible here. Okay, let's say we are asking this model to evaluate each particular transcript against the golden dataset and then give out an average score. So if the average score is less than 90%, reject that particular update. Okay, we can reject that particular update. And if the result is average is more than 90%, accept it. Okay. So does that make sense? Creating this golden dataset, this could be done using the superior models, or this could be done by like manually through human effort. Okay, they will manually analyze the transcript and they will generate what should be the output, how it should look like. Okay, we can't compare it directly. That's why we need LLM here, because we need to compare the meaning. Imagine a transcript fails here. We can put up this condition that if the transcript, so there are 3 agendas in the golden dataset and our application provides only 2 agendas. Okay, it says there are only 2 agendas. If this is the mismatch, then ignore all this average and directly discard the change that's happening. Does that make sense? So only provide the average score if the agendas match and most of the things match, but there is a certain mismatch. Maybe faithfulness is little less. There is an increase step in one response and decrease step in other response. Okay. So XML is something like it will create a flow. This data flows comes in the second step, the third step. Okay. It may be start off like so this is an agenda. Okay, this is the process. Step 1, step 2, step 3, such XML generation happens. Okay. So imagine there isn't this second step, which was not actually discussed. Okay, LLM hallucinated. We can ignore this unless it covers like 90% faithful. Unless all of the steps are accurate. Okay, only this is missing out, and but this can be valid. Okay, we will accept this hallucination because we can't completely eradicate hallucination. So we will accept this. If not, yeah, this trade-off comes in depending on like which business problem we are solving. So let's just say there is a finance, bank systems. Okay, that's why even when the AI advancement has gone like this big, right? So the banks are still hesitant to involve AI into their work systems because the financial data, the medical data, they could be like little tricky. They could be really tricky. Okay, one particular 99% of the time, the AI works good. So 1% will cost a lot. So imagine 100 among the 100 patients, 19 patients are good, and one patient. So he's healthy, but he is diagnosed by AIDS or cardiac arrest or sugar. Okay. So all this could be like very tricky. That's why in the medical and financial particular sections, those domains, we will be using less. We will be focusing more on this particular percentage. Okay. Let's imagine 98% is our threshold. And as of other business solutions, let's say admins control, like for our particular application, okay, 90% is good enough. Okay, admins just want to summarize the whole thing and understand the flow. So for that particular agenda, 90% is good enough. But for medical and finance, it could increase. Correct? Yeah, does that make sense, guys?
Yep, yep.
Yeah.
Navya?
Yes, yes.
It's understandable, right? From developers' perspective, we were solving a problem and then we are auditing the same solution.
Hmm.
So yeah, so we could be like these golden data set could contain only minimum 20. Okay, maximum it can be like whatever the number you want. Okay, depending on that data, it will every time there is an update, it has to check against this data, and depending on that, it has to pass that particular update or fail it. Okay, so by doing this, we will ensure every time the update is safe. Okay, the application doesn't drift a lot. LLM as judge, you already know the concept of like LLM as judge. So whichever the model we will be using as a worker agent or let's say reasoning agent in our application, right? So the same family model, we won't be using the model of the same family. Okay. So here, if we use OpenAI or let's say Claude, we will use something like a different model here. Okay, maybe Gemini, depending on the problem we are solving. So we'll be choosing those models. So all our QA infrastructure, what it does is, so our QA infrastructure will have this model, which will evaluate the work of the application, okay, depending on the traces and the golden data set. So it is to ensure that if there is an internal bias in those particular set of models, family of models, right? So we eradicate it completely. That's it. Mm, we will check for, yes, faithfulness. We'll check for precision, how precise the data is or the step is. Okay, adherence. Imagine, so this, for this precision, okay. Imagine an example, you call your friend, okay, F1. So you call him or her and ask like what's the day was, how the day went. Okay. He tells so he went office and something. Okay. So let's say he explains this in 3 steps. Right. And you call like a friend too, who is very talkative. So he may start with like how was his dream in the how was his dream and how did he wake up, when did he wake up and what did he do the first thing and how the day went. So in 50 steps. Correct. So while creating XML diagrams or let's just say there is a steps involved. So we have to explain step by step any of the output where steps, the number of steps are involved, right? So in our example, it is XML diagram. So here the model can answer in 50 steps and the model can answer in even 3 steps, depending on our prompt. Correct. How good they are, how bad they can get. Okay, that depends on the instance. It depends on the prompt quality. It depends on what's the requirement is about. Correct. So yeah, when I say precision, it's about like more number of steps increases the precision. Okay, but yeah, there comes the trade-off that it may start hallucinating. That makes sense. So yeah, so this is the concept which I explained, like having 90% for our particular tool. Okay. So faithfulness. So it has to be accurate with the transcript for around 90%. If yes, we are good to go. If not, we are rejecting the update. Okay. So yeah, so rejecting or passing the update, we will integrate this particular thing into CI/CD pipeline. Okay. So which we will explore later. Okay. So any doubts with particular this particular session?
No, no.
Nothing from my side too.
Okay. Yes. I mean, I can understand that. So this is more of a theory I'm presenting. So just to give you the point, so in most of the data science and AI, right? So you understand the flow better, and then the coding is not the important part here. Okay. So understanding like what need to be included and what need to be excluded and why. That is more importance. Okay. In traditional software engineering, it was more of, so you have to process, you have to create a process and you have to program that process. Okay. So in more in data science and AI tools, right? So it is more of like you have these presets defined for you. So whatever you want to use and why. So that becomes more essential part. So that's why it's more of theory. Okay. All right. If there are no doubts, we can end the session, I guess.
Okay.
So are we good, guys?
Yes.
Sure. Have a great evening, Saurabh. Have a great
Yes,
day.
yes, yes.
Thank you.
Please.
Thank
Thank you.
you.